We're going to illustrate and define some terms that we're going to take from set theory. We're going to do this at a fairly introductory level to start with, and this is to help us build up our understanding of the framework that we use for working with probability. So the first term we need is the idea of a sample space, and I will use the Greek capital letter omega to denote a sample space. What's a sample space? A sample space is a set of all possible outcomes for some, what we're going to call, statistical experiment that we carry out. So the next term we want, as well as the sample space, what we have within that sample space, the subsets, are called events. And we can have simple events or we can have composite events. And perhaps the best way to explain what we mean by this is by an illustration. So the illustration we're going to work with is a statistical experiment where we toss a coin 3 times. So if we toss a coin, there are 2 possibilities. It can either show a head or it can show a tail. So if we toss the second coin, what we would say is if the first coin was a head, then second time round we can either get a head or a tail, and likewise if we threw a tail the first time, the second coin could show either a head or a tail. And we continue this if we're going to throw a coin a third time. For each of these possibilities we can get a head or a tail. So in total, what we can see is that in our sample space there are basically 8 possible outcomes: a head, a head, a head, a head, a head and a tail, a head, a tail and a head, a head, a tail and a tail, and so on. And we can list out these 8 outcomes. These are our simple events within the sample space. So we have head, a head and a head, a head, a head and a tail, and so it continues. So what we have are our 8 simple events within the sample space. What we could define though is a composite event, such as the event that all 3 faces are the same. So this would be a composite event, because in order for this composite event we either need all 3 coins to show heads or all 3 coins to show tails. So what we have is a sample space, omega, which consists of 8 simple events, and we could denote these with some suitable notation, such as perhaps the lowercase symbol for omega. But we're not necessarily interested in these simple events. We can define any event we want, any subset we want within that sample space, and we suggested, for example, the event we were interested in was the event A, both faces the same, and this event is made up of omega 1 and omega 8. So we've defined the idea of a sample space, events within the sample space, and composite events that are made up of all these simple events. What we need to do next is introduce the idea of Venn diagrams, which is a way of illustrating some of the ideas we're working with here. The idea of a Venn diagram, we illustrate the entire sample space by this box. So omega is the contents of the entire box, And then we can illustrate the event we're interested in by a circle. So the event we're interested in, that all sides show the same face, is illustrated by this circle. And we can see the simple events that make up our sample space are all listed out, but the event A, denoted by the circle, which contains the events we're interested in. And then what's not in A, we can call A complement. Those events that don't fall within A, what is not A, denoted by A complement. What we can do with a Venn diagram is illustrate what happens with multiple events. So here there's been some rearrangement to the display. I've moved the simple events around a little bit, but essentially we still have shown here event A, which is the event that all sides show the same face. But I've suggested we define a second event, which is B, that two or more coins show a head. And we can sketch out B, which is these four events here. So we're now denoting event A, event B, and what's also of some interest, we've denoted a couple of other possibilities. We have something here known as the intersection between A and B. So these are simple events that are in both event A and event B. And the other idea that we could talk about is something known as the union. So this is events that are in A or they're in B. So the union would be these events here. And these ideas give us much of the background material we need in order to be able to start thinking about tackling probability. And we will look at illustrating probability with initially a naive definition from symmetry based on this illustration in the next mini-pod.